today we are talking about how to figure out if something is proportional. We're going to be looking at tables and graphs, starting off with tables. So first of all, we need to know what it means for something to be proportional. So two quantities or two numbers or two things are proportional if they have a constant ratio. So remember, ratio just means a comparison of two numbers, typically written as a fraction. A constant ratio means the ratio is always the same. For ratios that are not constant, so not the same, the two quantities are called non-proportional. So we're going to jump into some examples. It says use the table of values below. Write the ratios in the table to show the relationship between each set of values, then determine if there's a proportional or non-proportional relationship. So we talked about this a bit yesterday with figuring out the unit rate. That's what we are doing here, figuring out the unit rate. So we are dividing. Remember, money always goes first. So here our table tells us how many pizzas we're ordering and what the cost of those pizzas are. So the ratio, if you order one pizza, it's going to be $8 over 1, which is $8. So if you can simplify, please do. And then if we order two pizzas, our ratio is 16 over 2. 16 divided by 2 is 8. If we order three pizzas, it's $24. So 24 over 3. 24 divided by 3 is 8. The last one, 32 over 4, also gives us 8. Since we got 8 every single time, we can say yes, there is a proportional relationship. Because it has a constant ratio of $8 per pizza. Some people, when they look at a table, they look, oh, it's going up the same amount, but you need to be careful with that. It is going up $8 every time. Sometimes there is a pattern where it might be multiplied by the same number every time. That's not what we're looking for. We want to make sure it's adding the same number every time. So it went up $8 exactly every time. So that's why it ended up being a constant ratio. For number 2, determine if the table represents a proportional relationship and explain your reasoning. So here it tells us how many hours we're going to do something and how much money you are earning from whatever you're doing. So it's going to be the same concept. We're going to divide each row. Money goes first, so 20 divided by 5 is 4. And if I look at the next row, 50 divided by 10 is 5. So I already see that it is not a constant ratio. The reason why this happened is because it went from 20 to 50, so that was plus 30. Then 50 to 90, that was plus 40. So it did not go up the same amount every time. So we could say no, because there is not a constant ratio between, and then I'm going to say just the two things we're comparing, between hours and amount earned. So it's really good to be very specific with your answers. Use the words that they use. So we are comparing hours and amount earned. So not a constant ratio between hours and amount earned. On the next page, we're going to look at one more table before we get into graphs. So for number 3, still figuring out if it's proportional and explaining our reasoning. So when we have it this way, y always goes on top. So y goes on top. That has to do with something that we'll talk about in another chapter called slope, but y will always be on top. So here we have 3 divided by 2. 2 goes into 3 once with the remainder of 1 over 2, so that's 1.5. Then I have 6 over 4. 4 goes into 6 once with the remainder of 2, and that can be reduced to 1.5. So far we're looking good, but we want to make sure we go through all the numbers. 12 divided by 8. 8 goes into 12 once with a remainder of 4 over 8, which also can be reduced to 1.5. Still looking good. The last one, 14 over 12. 12 goes into 14 once with a remainder of 2 over 12. But 2 over 12 reduces to 1/6. So that was not the same. So we're going to say no. Okay. No, because there is not a constant ratio once x equals 12 and y equals 14. So that time, since we're just talking about x and y, I wasn't going to mention that in my labels besides saying x was 12 and y was 14 when we had an issue. This happened because when we went from 2 to 3, it went up 3. 6 to 12 went up 6, so it didn't go up the same amount. So that's why it ended up not being proportional. Okay, looking at a graph is really, really easy. There's no real numbers that you have to deal with. It's just looking at the graph. So for a graph to be called proportional, two things need to happen. First thing is it needs to be a straight line. So if it's curved at all, it's already no. The second thing is, and I shouldn't have said start at, it must go through, so please fix that. Go through the origin, which is 0, 0. 0, 0, if we look at A, is right here in the corner. If we look at B, it's right here in the center. So 0, 0 is kind of the start or the center of the graph. So looking at number 4, I first want to see, is it straight? Yes. Second, did it go through 0, 0? Yes. So this would be yes, because, oops, it is straight and goes through the origin. So origin is just another word for 0, 0. Part B, I want to see, is it straight? Yes. Did it go through the origin? No. It passed the origin. So we're going to say no, because it did not go through the origin. Part C, I want to see, is it straight? No. So it's already no. No, because it is not straight. Another word for straight line is linear. Sorry, I was about to sneeze. Okay, so it is not proportional because it's not straight, and again, another word for that is linear. The word linear comes from the word line, so I want a straight line. So if you use the word linear, then you're given a better answer than if you just said it was straight. Part D, we want to see, is it straight? So is it linear? Yes. And did it go through the origin? Yes. So this is yes, because it is linear and went through the origin. So make sure on those types of problems you explain your reasoning. Don't just say yes or no. Explain why. Okay, the last question. Number 5, a cleaning service charges $45 for the first hour and $30 for each additional hour. Determine if there is a proportional and non-proportional relationship between the cost and time spent cleaning. So first of all, I need to know that it was $40 for the first hour, $30 for each additional hour. So the first hour is $45, the second would be 45 plus 30, the third would be 45 plus 30 plus 30. So it's just cheaper after the first hour, but it will add up. Determine if there's a proportional non-proportional relationship between cost and time spent. So this tells us what two things we're comparing. We're comparing the cost and the time spent cleaning. You can do this two ways. You can make a graph or make a table. I think it's easiest to make a table. Since we're comparing cost and time, I'm going to make a table using cost and time. So it tells me what to use for my table. Just got to pay attention to it. So let's say that you hire the cleaning service for, and time I'm going to talk about hours because they were talking about hours. So let's say I hired the cleaning service for 1 hour. It says the first hour is $45, so it costs $45. Let's say I hired them for 2 hours. It'd be $45 for the first hour still, plus 30 for the second. So that would give me a total of 70. And let's just look at what about 3 hours. So I typically do just 3 points or 3 rows. So it's 45 for the first hour, 70 for the second, so I'm just going to add 30 since I'm doing an additional hour to get 100. So when I go to divide this, remember money goes first, so 45 divided by 1 is 45. If I look at 2 hours, 70 divided by 2 is 35. So I already see they are not the same, so it is not going to be proportional. So no, it is not proportional. Between cost and time spent cleaning. It didn't ask me for an explanation, but my work could be my explanation right now. So I just wanted to make sure I was specific with my answer. No, it is not proportional, so I answered the question. And then I was a little bit more specific. There's no relationship between the cost and the time spent cleaning. Okay, if you have any questions, please let me know.